Well, last section of chapter 14 is looking at catalysts and how they impact a reaction and the rate of reaction. So a catalyst, if you're not familiar with the word, catalyst is in its definition is what it is referred to in chemistry, and that's its ability to speed up a reaction. So it catalyzes or causes reactions to occur faster. And they do this by decreasing the activation energy, the amount of energy necessary for the reaction to go forward. It does some type of kind of slimming down, like what's required for the reaction to go forward. And so, usually what happens is the catalyst changes the mechanism or the process that occurs for the reaction. So rather than the shape of the molecule being one way, the catalyst being present will change or modify what the intermediate species are. So one way you could think of it is like a surface. It might be a substance or a substrate that is present in the material, and then the material comes in contact with it, and that is the catalyst or the location where the reaction will occur faster. So one way a catalyst can speed up a reaction is by holding the reactants together and helping bonds to break. So changing the reaction kind of in these so that the structure can change. Now you can also think, so you have in your car, you have what is called a catalytic converter, and so that is actually present so that it helps in the combustion process, or actually the post-combustion process, to get rid of some of the exhaust material that comes out of your engine is not fully reacted. And so what the catalytic converter does is you have, I believe it's platinum, or some really functional metals in those in your muffler system, and as the exhaust travels through that, it is catalyzed and reacts more completely, so you have less carbon monoxide and more just carbon dioxide in the process. Now, our bodies are full of catalysts because a lot of chemical reactions occur in our bodies, but we need to maintain kind of a relatively normal temperature, where most reactions without a catalyst would require a much higher activation energy for it to go forward. So a enzyme in your body is utilized to basically make reactions go forward and at much lower energy requirements, much lower activation energies. So what usually happens is that the enzyme is kind of this kind of lock and key situation where the enzyme's just present, and it just, when it comes in contact with material that it is shaped for, those materials come together, the enzyme does its work and breaks it apart, and then the products kind of go off and are consumed for whatever purposes it's designed for. So that is it for chapter 14, and we'll see you tomorrow.